Okay, so we have here now the solution for your problem number 2, no? So which is fire alarm system. Now what we have here are the conditions of your uh, fire alarm system, no? Okay, so this is where we will base our truth table. Now, from the problem, it also stipulates there the inputs and the output of your alarm system, no? For input A, we have input 001, input B, we have input 002, input C, we have input 003, and input D, we have 004. And we have here the outputs here, CR017, representing the red pilot light. And then you have the CR018, which represents your alarm or the siren. And then we have the output CR019, which is actually the notification of or notifying your fire department. Okay, so from this particular conditions, we interpret this using our truth table. So we have, as I've said, that we have inputs A, B, and C here. So we have here your inputs A, B, C, and D. Okay. Then the output CR017, which is your red pilot light, will now be represented by R, no? Or this one here. Okay. And then the siren will be represented by S. And then your fire department will be represented by FD. So these are your three outputs. Okay. Now, based on our condition, it says here if one input is on, then nothing happens. Okay, so we will not represent that in our output part of the truth table. And then the second condition says here if any two inputs are on, then a red pilot light goes on. So we have here inputs C and D are on, 1, 1. So we represent it with 1, and then we have another 1 here, and then another 1. So you have an output of 1, then 1, 1, 1, and then we have here 1, 1, 1. We have 3 ones here. So the output will still be equal to 1. Why? Because it says here any two inputs are on, that is the condition, then the output is, or the red pilot light will turn on, no? So if your B and C is turned on, then you have R is equal to 1, or C or D is turned on, then it is equal to 1, and that is what is meant by the word any. Okay, so if any two of the inputs are on, then the red light is on. Then we have here another 1 here. You have 2 ones, so you have the output 1, then 1, 1, the output is 1, then 1, that we have 3 ones here. So again, if any, so the output here is 1. And then you have another 1, 1, then 1, 1, 1, 1, 1, 1, 1, 1, 1. Again, if you have 4 ones, then it will still be equal to 1. That is the representation of your output red pilot light. For the siren, it says if any 3 of the inputs are on, then an alarm siren sounds. Okay, so if any 3, that means that we have here again 3 inputs is 1. So your output here is 1. Then you have 3 inputs here, this one and these 2 here. So the output is that's 2 only, no? For this one here, you have 1, 2, still 0. Then this one here, 1, 2, and 3. So the output here is 1. Then you have 1, 2, 3 again. The output here is 1. Then you have 1, 2, 3. Inputs are on. Then the output is 1. And then if you have 4 inputs are on, the output will still be equal to 1, because as I've said, when the word any, okay, the word any here is very, very important. So that means that if any of the 4 inputs, if any 3 of the 4 inputs are high, then the output is high. Then for the last one, if any 4 if any 4 are on, then the fire department is notified. So if all inputs are on here, 4 inputs are on, then the fire department is notified. Okay? So from this table, we obtain the min terms. No, we use the min term uh, procedure in the K-map for us to be able to identify the equations later on. No, for the min terms, for the red pilot light, so this will be our min terms. Now R as a function of A, B, C, D is equal to summation of min terms 3, 5. So that is the values here with are with the values of 1, no? That 1. So you have 3, 5, 6, 7, 9, 10, 11, 12, 13, 14, and 15. So that those are the output of the red pilot light with a value of 1. Then for the siren, what will be the min terms? S as a function of A, B, C, D is equal to summation of min terms. You have here 7, this one, then 11, then 13, 14, and 15. Whereas for the fire department, the min terms will be FD as a function of A, B, C, D is equal to summation of min terms 15 only. So this one only, no? Okay, so that will be your min terms. Now, okay, so let us now derive the equations for each outputs, no? The red pilot light, the siren, and your fire department. Okay, so we make use of our K-map, a 16-cell map. Why 16 cells? Because we are having a 4 input variables here, which is represented by A, B, C, D, and 2 to the 4 is 16 cells. Then, from the 16 cells, we locate the decimal equivalent for each cell. No? So, we have here 0, then 1, then 2, 3, then 4, 5, down, 6, 7, then side, 8, 9, then 10, down, 11, then 12, 13, then down, 14, and then 15. The next is to locate the min terms in the cells. So we have here 3, 5, 6, 7, 9, 10, 11, 12, 13, 14, and 15. So that is, this area here is the location of its min terms. Okay? Now, we obtain the equation using or by grouping the adjacent cells. So the grouping is 16, 8, 4, 2, 1. The maximum grouping is 16, and then if there is no 16 adjacent cells, we go to 8, and then if there is no 8 adjacent cells, we go to 4. If there is no 4 adjacent cells, we go to 2, and then we have individual cells 1. So in this case, there are no 8 adjacent cells. So we go to 4 adjacent cells. We have here the first for adjacent cells, which is represented by the yellow grouping. The yellow grouping is under variables A and B. And then the next grouping is the black group or the black grouping, which is under A and at the same time under B. And then the next grouping is the blue group, which is under B and under D. And then the next group is the red group, which is under C and under D. Then the next group is the orange group, which is under A and under C. Then the last group is the white grouping for adjacent cells, which is under B and at the same time under C. So from these variables here, we now obtain the logical equation by adding the variables that we were able to locate using the map. So this will be our equation here. So we have AB plus AC plus AD plus BC plus BD plus CD. So this will be our equation for the red pilot light. Now this equation can now be represented in Siemens by, for A, for example, I 0.1, for B, I 0.2, for C, I 0.3, and for D, I 0.4. That is for the input part of your Siemens. For the output, CR017, which is your red pilot light, will now be represented by Q 0.0, and then for CR018, which is your siren, represented by Q 0.1, and for the fire department, we have CR019, which is represented by Q 0.2 in Siemens. Now, in our previous discussion, we say that if the variable is multiplied together, if for example A, B, that will be represented by a 2-input AND gate, no? With an inputs represented by A and B. And when you say AND gate, that can be represented by a series connection in the form of contact. Okay? So we have here AB, which is I 0.1 and I 0.2 connected in series. And then you have plus, meaning to say you use the OR gate, no, for the plus sign here. Okay? Meaning to say that you have to connect A, which is I 0.1, and C, I 0.3 in series form to be connected in parallel with AB. Okay? So because of the symbol or gate, no? And so as with AD here, I 0.1 and I 0.4 in parallel with AC. And then you have BC, I 0.2 and I 0.4 added or parallel to I 0.2 and I 0.4. Then you have BD, I 0.2 and I 0.4 connected in parallel with your BC, and so as with your CD in series connection with I 0.4 connected in parallel with your BD. Okay, so this is your Siemens equivalent, and the output now, the red pilot light, will be represented by Q 0.0. Okay, so for the siren. So these are again our minterms. We have already determined that one. So let us locate that in our map. So for our map, there is no 8 adjacent cells, no 4 adjacent cells. So we go to 2 adjacent cells. So the first adjacent cells, 2 adjacent cells, is in the color orange, no? Which is under A, B, and D. Okay? The second group is your yellow, which is under B, C, and D. And then your third group is the red one, 2 adjacent cells again. So you have under A, C, and D. And then the last group, which is the black group here with 2 adjacent cells, you have A, B, and C. So the equation will now be, the siren equation is equal to ABC plus ABD plus ACD plus BCD. And then we represent that in our Siemens since this is now in network 2. So you have A I 0.1, B I 0.2, C I 0.3. Okay? Then you have again plus A I 0.1, B I 0.2, and D is I 0.4. And then you have A I 0.1, C I 0.3, and D I 0.4. And the last one is B I 0.2, C I 0.3, and D I 0.4. Okay? And these are being ORed, no? Because of the presence of your OR gate here, this one, no? Oh. So it is being ORed together. And then the output S here, the siren, which is represented by CR018, will now be represented in Siemens as equivalent to Q0.1. Okay, now for the fire department notification, so it has only one minterm, and that is 15. So we locate our minterm here, which is in 15. So you have only one cell which is present. So we obtain the equation for that particular cell, and that is under A, under B, under C, and under D. So you have A, B, C, D as your equation. So that will be your F or FD or fire department equation, which is equal to A, B, C, D. And this is represented by an OR gate. Okay? An OR gate, AND gate, no? And an AND gate can be connected, can be represented in relay form as in the series connection. Okay, so you have A, B, C, and D. And the output, which is the fire department, CR019, is represented by Q0.2. Okay, so this is how to solve a problem when there are conditions provided in the in that particular problem. But again, if in any case the problem stipulates that it has its own start, stop, seal, and interlock, then you have to make use of the solutions that we have in problem 1. But again, if the problem stipulates conditions, okay, just like in your fire alarm system, then you have to make use of your K-map, okay, solution for you to be able to obtain the equation. And from the equation, you can represent that in Siemens ladder diagram representation.